Welcome to the world of quantum technologies. Yes, in this discussion, in this video, I am going to discuss something about quantum radar. You know radar. Traditional radars are known to you. What is the use of radar, or what is the purpose of using radars? Radars are used to detect objects, and if the objects are in motion, here objects means enemies or targets. Okay, anyway, so you know the function of radar, I think. So objects are found out by using radar systems. Okay, and speed also can be measured by using radar systems. What happens in case of traditional radar systems? Radio waves are sent out, and the radio waves bounce off the targets. And by measuring the time gap, the distance of the objects can be known by the radar systems. I am talking about right now traditional radar systems. And by measuring the Doppler shift, because if the target is in motion, in that case, there will be a Doppler shift in the frequency of the returned radio waves, and by measuring that Doppler shift, the speed of the target can be known. So this way traditional radar systems work. But there is a problem with the traditional radar systems. If the enemy parties are using stealth technology, in that case traditional radar systems cannot detect those objects. In case of jammers, if electronic jammers are being used, in that case also traditional radar systems fail to detect the targets or the objects. In case of faint signals, traditional radar systems fail. Faint signals means I am talking about, say, small targets are there and the small targets are at a very large distance is located. The distance is very large and the size of the object is very small. In that case, the signal is very weak or faint. In that case also, traditional radar systems struggle. Okay, so to overcome these challenges, these problems, quantum radar systems are used, but there is no widespread use of this technology nowadays. In today's scenario, widespread use of quantum radar systems you cannot find, because the cost involved in case of a quantum radar is too high. It is too expensive. Again, there is many more problems are there in case of quantum radar systems. But what is the advantage of quantum radar systems? You know that I am talking about quantum radar right now. That means here the principle of quantum mechanics is used. Which principle is used? It is the quantum entanglement. Quantum entanglement of photon particles are used in case of quantum radar systems. Okay, so here this phenomenon of quantum entanglement, this is used to illuminate the object or the target. That's why this is also called quantum illumination. Yes, say two photon particles are there and they are entangled. Okay, so one photon particle is retained by the radar system itself, and the other one is sent out to the environment. And when the sent out photon particle is received by the radar system, in that case the comparison is made by the radar system, whether they are in sync or not. If they are out of sync, what are the states of the particles? So everything is measured after receiving the photon particle which was sent to the environment. Okay, so that way the phenomenon of quantum entanglement is used in case of quantum radar system. You know that quantum entanglement, I think this phenomenon is known to you. If two particles are entangled, then in that case change in the state of one particle immediately affects the change in the state of the other. Whatever be the distance between them, That means it happens irrespective of the distance between them. Even if the distance is in terms of light years, then also this is true. The phenomenon of quantum entanglement. So same phenomenon is used here, but instead of using any particle here, only photon particles are used in case of quantum radar system. Okay, so out of two particles, one half is sent out to the environment and the other half is retained by the radar system or the radar receiver. Better to say radar system. Other half is retained. And after that, when the particle, the photon particle which was sent out, when it is received by the radar system again, then the comparison is made. And by making this comparison, everything means I am talking about the requirements. Requirements is the presence of the object, location of the object, speed of the object. Everything can be known. And one more thing, one more advantage with quantum entanglement is that if the size of the target is very small, in that case also, it works well. The quantum radar system works well in case of very weak signal. That means if the distance of the target is very large, then in that case, no problem at all. There is no problem at all with quantum radar systems. If the size of the object is very small, in that case also there is no problem at all with quantum radar systems. That means very faint signals can also be detected by using quantum radars. Again, in case of high noise environment, means the target exists, target is located in a very high noise environment. In that case also, quantum radar systems are able to distinguish between the environment and the object. And that way, quantum radar systems are able to locate the target, to measure the speed of the target. Even the size and shape of the target can be known by using this radar technology. Okay, so and you know the use of radar technology, many uses are there in case of military or defense, means military, in case of military applications, you will find application, the use of this radar system. In other cases also, radars are used. Radars can be used. Anyway, I am not talking about the area of use of these radar systems. I was just focusing on the technology, the science behind this technology. And the science is what? Here, science is mainly quantum entanglement. The phenomenon of quantum entanglement is behind this technology. Anyway, research is still going on so that this radar technology can be used by wherever it is needed. Okay. Anyway, so this was all about today's topic, quantum radar, the next frontier in detection technology. Yes, no doubt, it is used for the purpose of detection. Anyway, so this is the end of this video. Thank you for watching this video.